I'm Mike McCaffrey.
Lindsay Kroger.
Nick Felker.
I am part of the CNDH subsystem for the MemSat project.
Command and data handling.
Our main challenge is how to take all the different subsystems and interface them together to create a single cohesive MemSat.
The hardware that we're using, which is the Pumpkin motherboard with a PIC daughter board, we need to be able to allot different memory spaces and different pins accordingly so that nothing is interfering between each subsystem.
Power, comms, ADCS, and payload.
The second constraint is the timing window. So we can't always communicate between the CubeSat and the ground system.
For example, we have a 30-minute quiet time and 45-minute radio silent time that we need to adhere to after deployment.
So the experimental memristor payload is our biggest priority. We need to be running that experiment as much as we possibly can while we're up in space. However, we have about 10-minute periods about 3 times a day to be able to communicate. The windows, we need to make sure that we take advantage of that and we are communicating and not doing other processes on the MemSat at those times. We need to be able to monitor the power while our CubeSat is in space. We need to check the system health periodically and make sure that the correct amount of power is being allotted to the correct subsystems at the correct times.
We are using several different communication standards, SPI, I2C, and UART. A big part of making sure MemSat is successful is around testing. So we are doing several iterations of testing. First, we have local tests, which we are communicating to the microcontroller through UART and a Python script running on a laptop. This runs through very simple tests to verify functionality. We're also working on integration tests.
I am the testing liaison for the systems integration team. We have a FlatSat mock-up of our satellite where we will be integrating all of our subsystems and making sure that we meet those timing requirements.
So the next constraint that we have is risk mitigation. So when you put anything in space, there's always going to be that risk of radiation causing bit flips or code corruption. How we take care of that on MemSat is having everything stored in triplicate. So we will always have 3 copies of our initial, our current, and an updated version of the code. So if there's ever an issue with an updated version, we can go back to the previous version. If there's an issue with that, we can go back to the initial version. And again, everything is stored in triplicate as well, so we can do a majority rules. So if one portion of the code seems to not be functioning, we can check the other 2 pieces of code, and if those seem to be working properly, then we can use one of those rather than having to revert to an older version.
We are also using continuous integration in order to verify that the code you're writing is syntactically correct every time we do a new commit.
We need to be able to allot the proper portions of the flash memory to the different subsystems, so we need to be able to store the triplicate of the motherboard code. We need to be able to store data that we're getting from the payload experiment or any other subsystem that needs to be able to communicate with us until we are able to actually send that data down to the ground station and clear it out of the flash memory.
What I really enjoyed about the MemSat Clinic project was the integration between teams. So it's one thing to develop a system in isolation, but to coordinate that subsystem with many other subsystems is a bigger challenge, and it requires a much more coordination among many more people. And that challenge was something that was unique to the MemSat project by far.
I think that my favorite part of the clinic was being able to work with so many different types of people and so many different subsystems. Normally when you're working on a project, it's just one small group of people working on one processor or one portion of the project. And being on MemSat, I actually had to work with not just the command and data handling system, but with attitude or payload or communication, and that's something that you're going to have to use in everyday life when you graduate, so I think that's great.
My favorite part about the MemSat is that the true MemSat was the friends we made along the way.